Okay, while we're waiting on some parts to arrive for other projects, I thought we'd take a look at this little guy. This is a Pilot FM tuner from about 1947, 1948. It's called a Pilot tuner, and it covers the standard FM broadcast band that's still in use today. Its purpose was to add FM capabilities to AM-only receivers. You just plug the tuner into the phono jack or the auxiliary input jack of your existing radio, and voila, you have FM reception. So let's pull this thing apart and see what we can do to it. Hopefully won't be much wrong with it, and we're not going to just plug this in. The power cord is rather exposed here at the plug, if you will. Well, here's something unusual that I've never seen. Notice this chassis mounting hole, how it's intact. Notice this chassis bolt hole here, and notice how it's all broken out. In fact, that particular bolt wasn't even catching on to anything. Now, look at the inside of the cab. Notice this area of wood that got busted out somehow or another. And here are couple of chunks of wood that were laying inside of the set. I have no earthly idea how that happened, but it can be fixed. Here's our chassis, a 5-tube chassis with a power transformer, and it uses a selenium rectifier for the power supply. We have our RF amp, mixer tube, first IF tube, second IF tube, and detector tube. So should be a pretty decent little tuner once it's all fixed up. Here's the underside of the chassis. As you can tell, not much in the way of capacitors that need to be replaced. We have this electrolytic here, and I believe this is a mica bomb across the line capacitor here. There's our selenium rectifier, and there's a few paper caps in there, but not many. Here's our mica bomb AC line bypass capacitor. It's going to be less work involved in replacing this one because it wasn't even soldered to the terminal here. Yeah, this must have been one of those Friday jobs where they were in a hurry to get out for the day. But yeah, unlike on the Crosley video, I bet I don't get any accusations from anyone accusing me of unsoldering this capacitor before making the statement that I just made. Like I got on the Crosley video, someone accused me of breaking the belt on that record player, so I could tell everybody how crappy it was. Okay, I've replaced the power cord as well as the AC line capacitor, bypass capacitor. Yeah, this new capacitor is a good bit smaller than the old one. I have the DC voltmeter connected to the output of the selenium rectifier. I'm using the signal tracer as an audio amplifier so I can see if we're getting any audio output from the tuner. I'm going to fire everything up, monitor the B+ voltage, see if we get any desirable output here coming out of the signal tracer. Okay, we're only getting about 47, 48 volts off of the selenium rectifier, which is low. We're getting filter capacitor hum. However, I can detect that a station is coming through. Okay, so let's replace the filter capacitor here, and then we'll go from there. And checking the first section of this filter capacitor, it's supposed to be 40 microfarad. We're reading only 2 microfarads, and we can assume the other sections are just as bad. So, yeah, further proof that this capacitor is toast. Now, let me get creative and see how I'm going to mount the replacement capacitors. Okay, here's the old capacitor. We have two 40 microfarad sections at 150 volts, a 20 microfarad section at 150, and a 2 microfarad section at 150. Now that's the stabilizing capacitor in the detector circuit, and I don't believe you're going to need 150 volts there. A 50 volt capacitor should work fine. Looks like 296 is probably the source code. 737 is probably the 37th week of 1947. Well, unfortunately, we have a problem. I've replaced all of the filter capacitors, as you can see. And now when I fire it up, I get no stations at all. And this resistor is running very warm. One end of the resistor connects to the first filter capacitor. The other end of the resistor connects to the second filter capacitor, as well as some branches where DC goes in different directions. Well, checking at this end of the resistor, I'm reading, let's just say 500 ohms from the output of this resistor to chassis. Now that means that something is loading the circuit down somewhere. Now let's see what we have here. This resistor goes into this transformer here, which I believe is the discriminator transformer, or the detector transformer, whatever kind of detector this thing uses. Okay, and then we have another lead going back up here to this filter capacitor here. There's also a big mica capacitor connected between there and ground. And we have another B+ lead going back over here. And we have a resistor coming off of this tie point here. Well, it'll be easy to eliminate this problem. On this end of the resistor, we're reading the 494 ohms. And when I move to the other end of the resistor, right there, we're reading infinite resistance. So that tells you that our short circuit is not here. So we've eliminated one branch by this process of elimination. So now we need to check these other branches, and the only way to do that is unsolder each one at a time and make a resistance reading to chassis ground and see what the problem is. Okay, I now have all of our branches disconnected, so we will individually test each branch. We'll test this new filter capacitor. We'll test from this big mica capacitor to ground. We'll test from this red wire to ground and the orange wire to ground. And then we'll follow where the meter takes us. Okay, we're now checking from the red wire to ground. We're reading 494 ohms. And this red wire runs back up in here to the front end circuitry. Provides B+ to that stage. So, this is the area we need to investigate. Now let me mention one thing concerning resistors. Over the years I've had people ask me about a burning resistor in their radio. Well, I need a 470 ohm resistor. Mine keeps burning up. Well, just a little service hint. Anytime a resistor overheats, there's something causing it to burn up. Resistors just don't overheat and burn on their own. When a resistor burns, there's something that's drawing too much current through the resistor, which is exceeding its rating and causing it to burn up. So when you encounter a resistor in a piece of equipment that's overheating, you don't just replace the resistor unless you like smoking resistors unnecessarily. You need to find out what's causing the problem, and the way you do that is how we just demonstrated with the ohm meter. Look for an abnormally low resistance to ground, and then once you find it, correct the problem and then replace the resistor. Okay, our red wire comes around over to this terminal strip here, and on the meter you can see we're still reading a short, and coming off of this terminal we have several resistors. Here's a resistor here that one end connects to the terminal, the other end connects here. which connects to a capacitor, and the other end of this capacitor connects to ground, the chassis. So let's test right here. This ought to be a good point to test. And look at what we have, 0 ohms. What do you want to bet this capacitor has shorted? So let's unsolder one end of it and test it. Okay, there's one end of our capacitor cut loose. Let's check and see what we have now on the meter. We have infinite resistance. Now let's check at the capacitor. Come on, get on here. And look at that. This capacitor is dead shorted. Here's our capacitor out of circuit, reading dead shorted. Let's see what value this thing is, and hopefully I have one. Here's our capacitor replaced, a 0.01 microfarad. And look on the meter. No short. So let's hook the signal tracer back up and power it up again and see if we can get some reception. It would have to be better than what we had before. Well, that's a lot better.
AM WMER Meridian.
That's the FM simulcast at that station.
Come to another message on God, I need some answers. These are questions from the Psalms that are answered in the Psalms. Bible class meets every Sunday morning at 9 in Magnolia Restaurant in Queen. Country.
It's always uplifting and good music.
I listen to it almost all day.
97.0 KK.
The kind that carries all your love.
Friends say I was passed out on the dirty couch feeling.
Call 210-73.
I want to make sure every American is listening today. This is the Lord Larson Show.
Like a plane, let me guide that on the pilot.
Okay, well that sounds pretty sensitive. Now, that distortion might be due to this signal tracer, but we are going to go ahead and replace the rest of these little ticking time bombs. And that should help the situation a little bit, but I'm very pleased with the progress that we're making so far. A while back when I ordered capacitors for my stock, I accidentally ordered some capacitors with extremely short leads, these things right here. For some reason, it didn't occur to me at the time that there are actually capacitors made with short leads on them. So what I do, in a situation where I don't need much lead length, as in this situation here, I use these smaller capacitors with the short leads. And in situations where I need extra lead length, I use the more traditional style capacitors that most everybody orders for their antique radio restorations, the capacitors with the nice long leads. So, you know, I don't believe in just letting parts just sit around unused. If I can figure out a way to use them, I'm going to use them. Okay, I'll replace the rest of the capacitors.
details there on the floor of the New York Times.
I'm always happy to help you choose the perfect rug for your decor.
Okay, tomorrow I want to hook this to a somewhat decent amp that will give me a little bit better fidelity than this signal tracer, and that'll give me a better idea of the current condition of this thing. And I'll clean the tube sockets to where they'll make better contact. I might even replace the selenium rectifier with a diode and kind of touch up the alignment, and this thing ought to be good to go. Okay, I think we're about ready to button this thing back up. I ended up having to replace the selenium rectifier because after it warmed up, the B+ voltage started dropping. So I just replaced the rectifier with a silicon diode, 1N4007, with a 27 ohm resistor ahead of the diode for surge current limiting and to drop the excess voltage. Okay, here we are back together, and I have it plugged into a little Coronado AC-DC set from the late 50s with a phono input.
Everything that stays, there's a danger. Crash like a rain falls down on me.
I think that's as futuristic as Tomorrowland always is.
I would say late fall. And how do
Now, I will say this thing doesn't work too well when the tuner is not plugged into an isolation transformer. That's what I get when I have the tuner plugged directly into the AC line. I don't think that would be a problem if the tuner was actually plugged into a set, into a radio that contained a power transformer.
That's reportedly the most expensive single ever produced.
Which is what this set would be.
Well, the cost of making a single,
what this tuner would be plugged into.
$5,000. And it's unheard of for someone to spend twice that much to produce a single.
Would there be help for that too?
yeah.
On this kick, and so we're, are you doing?
Now, I have not done anything to the alignment yet, mainly because I still haven't purchased an ink cartridge for my printer, and I want to be able to print the alignment instructions out and have them in front of me before I do that. But this thing seems to be working fairly well as it is, so, an alignment is really not critical at this point.
AARP. Why would you wait
And I need to make up a proper shielded cable for the audio output of the tuner. We can't have this mess.
With the free 97.0 KK Apple and Android app, now you can hear it.
Pretty much everything below 95 is either religious stations or public radio.
behavior is going to take you to a place that you don't want to end up.
Reach beyond.
Hi, this is
Microphone.
Well, here we are.
But yeah, it seems to be working okay. Okay, I tried reversing the plug of the radio here, which has a hot chassis, and that still didn't solve the hum problem. So apparently this tuner does not like to be plugged into a radio or amplifier that uses a hot chassis, but like I said, that's not a big deal because what I'm going to be plugging this into will use a power transformer, so shouldn't be a problem there. However, if I plug the radio with a hot chassis into the isolation transformer instead of directly into the non-isolated outlet, then it works fine. Okay, well that ought to do it. That's about all I've got for the pilot tuner for right now. Maybe one day whenever I get the alignment instructions printed, we'll go back through it and do an alignment on it, but as it is, it works fairly well on local stations, and that's all I really need anyway. So thanks for watching, and more to come later.
In the daytime, I'm Mr. Natural, just as healthy as I can be, but at night I'm a junk.